Good morning and hello, everybody. Good to see you all. Well, today we've got a lesson on logs, but before that, let's start with a joke. Why did the banker quit his job? He lost interest. Okay. So as we said, today we're going through logarithms, and today is just going to be a little bit of a review. And let's just go over this real quick. Now, the definition of a log, let's not have that way. The definition of a log, if y equals to log ax, then basically what that means is we have base to the power equals our numeral. So a to the y equals to x. And so that's how we interchange between the two. And we'll have a little bit of practice between how to convert those between logarithmic form and exponential form. So speaking of exponentials, it's the inverse of an exponential. So that means if you kind of put them together, they end up canceling each other out. Very similar to plus and minus, times and divide, they cancel each other out. So if we have e to the log ex, e to the log e will cancel out, and we're just left with, or log e and the e will cancel out, and we're just left with x. So they're inverses of each other. And also another thing to note is in your calculator, you'll have two buttons. One will say log, the other one will say, it looks like in, but it's ln. So log means that we're dealing with log base 10. ln means that we're talking about log base e. And this is the one that we end up using for most of our mathematics. It's not that we don't use the other one, it's just you'll probably use ln a lot more. Right? And graphically speaking, what happens is because it's the inverse, it's going to look literally the opposite of y equals e to the x. So that means if I was to flip it, it would kind of go a little bit like this. We know that normally it's supposed to cut at 1 for the exponential. So it makes sense that it's going to cut at x equals 1 for our log. And it's actually going to have an asymptote here. And it's kind of going to go this way. And that there is your y equals to log ex. That's your graph. And very similar how you can dilate the exponential, like y equals 2ex or e to the 2x. You can do the same thing here, 2 log ex or log e 2x, and it just kind of changes where it may cut the x-axis, or it changes how steep the gradient is. All your general rules apply. Let me suggest, if you are not familiar with it, go back from your year 11 stuff and take a look over how to graph these logarithmic functions. All right, because today we're going to go a little bit more. There's a couple things to remember here. These are going to be very important for the work that we do today. And again, this is a review of last year. If you have log e of e, this is basically saying e to the power of something gives me e. Okay, so have a pause, and with that in mind, see if you remember these. Pause the video here and see if you can remember what each of these are. You should have paused, but if you didn't, let's go through them anyway. If we have log e of e, then yay, it's just 1. Okay, if we have log e a to the x, then the special thing about log is it allows us to take the power all the way out the front. So this can be rewritten as x log base e a. So I've just removed the power from the a and moved it all the way to the front of the log. That's what a log does. And the other important one here is we have log e1 is 0. So e to the power of 0, e to the power of 0 gives me 1, which makes sense. So whatever it is, if there's log e of 1, it's always going to be 0. And in this case here, e to the power of something gives me 0. We know that an exponential actually never equals 0. So this is what we say undefined. Yeah. So log e 0 doesn't happen, doesn't exist. It's undefined. And it's actually going to give us this asymptote here. I don't know if you can see that kind of x equals 0 line. Yeah, but I'm just going to get rid of that because I don't want it to be too messy. All right, now that we've got that under the way, let's try work at some of these simplified ones. So we see log EE. You know what, if you're in class watching this, I want you to have a go, pause the video for about 2-3 minutes and see if you can convert these or simplify these, okay? Pause it, better pause it, try it. Okay, hopefully you should have tried it out, man. It feels so weird waiting, and I hope you guys paused. Okay, if we've got log EE here, the answer should be 1. If it's got log E7, remember the log E and the E will end up canceling out. And we're just left with 7. Or if you want to think about it, the 7 will move down to the front and then leaving us with log EE, which again is 1. So 7 times 1. You've got options there. I'm just going to get rid of that across. Try to make it as neat as I can. Now, if I have log E to the 1 on E squared, that's log E to the -2, which is just going to be -2. And E to the power of log E 27, the E and the log E cancel out, leaving us with just 27. Okay. Now, have a go at these convert ones as well. Hopefully you have. If we're doing these convert ones, the way that this would go is, this would mean that log base E of X equals to our power 4. Okay, same thing here, log and our base is E, so log base E of our numeral 16 should equal to 2. If we have log EX equals to 7, then that means we're having the base of E. It's going to be to the power of 7 equals to our numeral X. And same thing here, we're going to have E, and the power should be X, and the thing it should equal is 10. So I don't need all these equals here, but that's what it would look like if we had converted these from exponential to log form or from log form to exponential. Okay. Now, there's one more thing that we need to go through. So it's a bit of a long one today, but today we've got change of base. This is going to be helpful for us, especially when our base is not in E, because like we said, in your calculator, you've only got base E or base 10. But I'll show you what we do here. So if you have log of some other base bx, the way it's going to be rewritten is we can rewrite it with log e, but it's going to be log ex over log eb. Okay, so it's just kind of like that term stays on top. That term here goes to the bottom, and that's going to be the way that we change our base. Now, I don't have a calculator on me at the moment, but let's put this in our calculator. I'll see if I can grab one in a bit. Now, if we have log 4166, notice this base is not E. So that means I'm going to have to calculate it using a change of base if I want to find out what it is. So that could be the same thing as writing log E. And I'm going to pick the larger number, or in this case, the 166, the number that's not a base. It'd be log E 166 all over log E. And now I pick the base, which is going to be 4. And if I put that in my calculator, okay, should have done this earlier. Now remember, log E is ln on your calculator, so ln 166 over ln 4. And let's go ln 166 over ln 4. Close the brackets, equals, and to one decimal place, that would be 3.7. Okay. Hopefully that helps, and enjoy. All right, I'll see you guys in the next video. All righty, bye-bye.